My name's Professor Andy Lowe. I'm Director of Agri, Food and Wine here at the University of Adelaide. And I'd like to start by acknowledging the Kaurna people, the original custodians of the Adelaide Plains, and the land on which the University of Adelaide's campuses of North Terrace, Waite and Roseworthy are built. Thank you all for coming, and tonight's Research Tuesday event is What's the Buzz? Tonight we'll turn our attention to bees, and I'm sure many of you will be aware of some of the problems that bees are facing, some of the decline that's been recorded in bees, and some of the problems that will result for many of our ecosystems. And to take us through this topic tonight is Dr. Katja Hogendoorn. But Dr. Hogendoorn will not just give a story of despair. She will also give us some hope for the future and what we can do practically about some of the bee declines. Katja is a postdoctoral research associate in the Plant Protection Group in the University of Adelaide School of Agriculture, Food and Wine. Her research focuses on the maintenance and enhancements of bees as pollinators, as well as more generally the evolution of bee behaviour. And Katja currently leads a large research program, she told me to say it's together with me, on how we can help support pollinators and help revegetate landscapes to support those pollination services. And this large research project is in collaboration with government agencies and also key industry groups that rely on pollination services for the crop production. I've had the pleasure of listening to Katja talk at public events on several times, and you're in for a real treat tonight. So I'd like to welcome Katja to the stage to talk tonight. Thank you.
Thank you all for coming tonight. Can you hear me okay in the back? Yeah? Good. Thank you. Let me know if that's not the case and I'll turn the volume up. So I research native bees and honeybees, and I do a lot of community talks. And during these community talks, I always get a lot of questions, and some of them pertain to bee declines. Are the bees in decline? Why are the bees dying? Is this happening in Australia? What happens when the bees die? What can we do about it? And then inevitably, are we all going to die? Well, that last question is always the question where I think, well, that is reinforced by some of the thought experiments that are happening. One of the thought experiments is, and a very known citation, if the bees disappeared from the face of the earth, man would only have 4 years of life left. Now this is a citation that traces back to 1965, but also is said to be a citation from Einstein. Einstein was 10 years dead when this first surfaces, so it's very unlikely that he actually said something like that. A next one is from 1941, and then Einstein was still alive and kicking then, and it is more than 100,000 varieties of plants would disappear. It's very unscientific, and you can trace it back to Maeterlinck. And Maeterlinck was a beekeeper. He wrote a book, The Life of the Bee. The book is an exuberant, poetic book with more attention for life than for bees, and it is really very unscientific. And then in these days, there are shorter texts that have the same message, such as, if we die, we're taking you with us. Well, we need to fact check that. And another one is imagine a world without bees. And then we see a supermarket shelves full of produce, fruit and vegetables, or dairy. And a world without bees drastically reduces our fruit choices and our dairy choices. Now, some of that is actually true, but not all of it is true. For instance, canola doesn't totally rely on pollination by bees or insects. They do a lot of self-pollination. So we need to do, again, some fact checks. But pollinators, nevertheless, are crucially important for ecosystems. 80% of all flowering plants benefit from animal pollination. That doesn't mean to say that the plants all wouldn't reproduce without animals. It's just that they set more seeds when there is a pollen vector bringing the pollen from one flower to the flower of another plant. But some, and a fair few, rely completely on pollinators. And the main pollinators are bees. Why? Well, because bees rely for the whole of their life cycle on the products of flowers, pollen and nectar. And because they do rely for that whole of the life cycle on pollen and nectar and have developed hairs to collect that pollen, they really are the vector of choice for many plant species. And the beauty you see in flowers generally advertises to pollinators, come and visit me. I have got good resources for you. So all that beauty out there, it's for pollinators, really. So also, bees are very important for food crops. 75% of our food crop species benefit from animal pollination. And our staple foods do not. So wheat, rice, potatoes, we would have. We would not starve without pollinators. It wouldn't be the end. There goes Einstein out of the window. And that 75% of our of those crops is about 30% of our diet. So if you hear 1 in every 3rd bite thank a pollinator, that is that 30% of our diet. But that 30% of our diet contains 75% of our vitamin C, vitamin A, E, calcium, fluoride, iron, and 95% of something very important for pregnant women, folic acid. It's not only fruit, it's also vegetables and seeds, sunflower seeds, hybrid vegetable seed, seeds of food for livestock like lucerne. And altogether, the importance of pollinators, if you quantify that in economic terms, is about 9% of the world crop production in GDP. And for Australia, that would mean something between $2 and $6 billion. I find it always hard to get a concept of that kind of money. For South Australian crops, we have 4 crops that are really important in the South Australian economy: almond, lucerne seed, canola, and apple. Almond and lucerne rely for 100% on pollination. Without them, the plants wouldn't produce any seed. Canola, you get a 15% increase in market value if you have good pollination. And for apple, they say it's 80%, but it's really between 80 and 100%. So that's how important it is, and that has an astronomical value of around 300 million a year. Okay, which ones are those bees? Well, firstly, we have the managed honeybees. The managed honeybees are in hives. We've got other honeybees as well, the feral honeybees. They're the same species as the managed honeybees, but they have just gone and lived in tree hollows. The managed honeybees were introduced into Australia in 1820. So before that, Australia went by very well without any honeybees present. The honeybees are a very weedy species. They're also our most important crop pollinator. Don't get me wrong. They're also a very weedy species. They compete with birds, native bees, mammals, and hive bees for nectar, pollen, and nesting hollows. And they are abundant in areas with old trees, and they rely on water. So you generally won't find them in the arid center. What we don't know is their abundance in cropping areas and their contribution to our food production. And we're trying to quantify that, and I'll explain to you why. And then we have Australian native bees. There are 1,700 species described and 50 species on crops. There are also other pollinators, wasps, flies, moths, butterflies, beetles, and together they pollinate on average between 0 and 30% of crops. It really depends on the crop. Take, for instance, avocado. Honeybees hardly pollinate avocado. It's flies that do the job. So with pollination, even of crops, it's often horses for courses, but honeybees do a really good job because they can be transported and put in large numbers. So now that we know what kind of bees we have, that sets the stage for asking, are the bees in decline and why are the bees dying? What's happening globally with managed hives, feral hives, native bees, and later on I'll be talking about what's happening in Australia. Now, around 2005, the world all of a sudden woke up to a syndrome called colony collapse disorder. What happened was mainly in the USA and Europe, and beekeepers would come to their hives after winter, and the hive would be full of food and there would be brood there, but the bees had disappeared. So this was real, people didn't know why, people had no idea why this was happening. And of course, the media jumps on something like that, especially if it's not known. So, are GM crops killing our bees? Is it new nicotinoids? Is it caused by climate change? Bees are killed by mobile phone towers. It's Israeli acute paralysis virus, we found it. And then our bees caused that because they found that that virus came from the bees that they had imported from Australia to make up for the shortages. But that virus was around the world already plenty of times, and we in Australia have that virus but didn't have those problems. So that refuted that then. Okay, by now we still don't really know, but what we know is that the colony collapse disorder is a multifactorial something. So lack of food and monocultures and pesticides all work together to decrease the resistance of bees against diseases. And when the bees are resistant against diseases, they can then become sick during winter, and pesticides also help to make bees confused. So, and they cannot find their hive back. So there are several things that work together that affect honeybees and affect them quite badly. But there is one thing that stood out above the rest, which is the Varroa mite. And the Varroa mite has several influences. And the Varroa mite jumped from Apis cerana, an Asian honeybee, to Apis mellifera, our honeybee that we have here, although Apis cerana has also arrived in Australia a few years ago. So, and as we see as humans often, when diseases jump from one species to the other, like HIV, like swine flu, they can cause havoc because we haven't got any defenses against them. And that is what happens with the Varroa mite. And it was first seen on honeybees in the 1960s, but in in Japan and the USSR then, and then by the 70s it was found in Eastern Europe and in South America. By the 1980s it was found in North America and in Western Europe, and in 2000 it arrived on the North Island of New Zealand, and then despite all the biosecurity around it, it still managed to get itself to the South Island where it was found first in 2006. So our neighbors have got that mite, on their European honeybee, and there is no doubt, nobody who studies bees doubts that we will get that at some stage. So what we need to do is know what consequences are and prepare for that. So hives need to be managed for the Varroa mite, but what we are talking about here is bee declines, and the question is, did the Varroa mite lead to massive declines in managed hives? And for that, we can look at data from the FAO, and they estimate the number of millions of managed hives over the world. And what we see is that since the 1960s, but definitely since the 1980s, there has been an increase in managed hives. So far, so good. There weren't any real declines. The little blip that you see around the 90s is caused by the fact that the subsidies in the USSR changed, and people got less hives to make honey because of that. So that is what explains that. And so what we see is managed hives nearly doubled since the 1960s. Beekeepers are in all those countries with the Varroa mite, so they know how to manage for that. And hived honeybees are really like farmed animals. It's, if we would ask, are cows in decline? Nobody would really ask that, because we can breed them. We can breed honeybees fairly well. And that is what we have learned to do, even in the face of several diseases. But there's a different side to this. Between 1961, when this time series starts, and 2017, 2.5 times more land is used for agriculture. There are 2.5 times more mouths to feed as well. And there are 3.5 more areas with pollination-dependent crops. And there are fewer unmanaged pollinators, as we will see. So managed hives did not keep up with the pace of production of pollination-dependent crops, and there is an increasing demand. The managed hives that are out there are worked a lot harder worldwide for pollination these days. In the US, very few people produce honey. You can earn much more with pollination, and they travel around the world with their hives for pollination services. So, what happened to feral honeybees? Well, the losses were huge when the Varroa mite comes in. 95 to 100% losses in the USA and in Europe. Why? Well, the Varroa mite replicates on honeybee brood, but that's not the main issue. The main issue is that it is a vector and an incubator of viruses. It delivers them directly inside the bee, and they don't have to go through the gut. And there are defenses in the gut that wouldn't allow viruses in. But the viruses that come in directly, the bees haven't got the defenses against. And they get more and more virulent and change through the cycle within the mite. So what we see is high losses of hive bees and feral honeybees in areas with cold winter. In areas that are warmer, like Brazil and Africa, the feral honeybees keep existing. It seems that it is harsher for areas where development is relatively slow and bees live long. And not only does Australia not have the Varroa mite, it also does not have one of the main viruses that works together with the Varroa mite, deformed wing virus. And if you look here, you see that that honeybee has no wings. That is what deformed wing virus can do. It can also cause death, but it can cause bees without wings. Of course, they can't fly. They can't collect anything. So others have shown that that virus doesn't occur in Australia. We have shown that it also wasn't introduced together with the bumblebee when the bumblebee was introduced into Tasmania in the early 90s. And Beth Fung in my group has demonstrated that. So Are honeybees in decline? There's no decline in managed hives, and we can manage the Varroa mite. There's substantial declines in feral hives, and there's no decline of feral hives in Australia. Feral hives are actually doing fine, especially in Adelaide. What about native bees? Well, native bees are stunning animals. They've come in all colors of the rainbow. They are sized between about 2 millimeters and 12 millimeters in body length. Oh no, 2.5 centimeters. There are about 20,000 species in the world, which is about 4 times as many as there are mammal species in the world, 2 times as many as there are bird species in the world. They are phenomenally diverse. They're nearly all solitary. They have no queens and workers. They produce no honey. So they are quite different. Australia has about 1,700 species. And we have some evidence of declines of native bees. Laura Burkle in 2010 investigated forest patches early spring, flowering on the ground for bees. And those same patches had also been sampled in 1890 by someone who meticulously recorded what he had done so she could do it again. And she also looked at pollen deposition on a plant species, and she could compare that to 1997. And what she did is she made a plant pollinator network. Now, that sounds maybe very complicated. It definitely looks very complicated, but it really isn't. What you see on the top are depicted all the bee species that are found. And on the bottom are depicted all the plant species that we found relative to their importance in the landscape, so their presence in the landscape. And what Laura found was that when she compared 1890 to 2010, 50% of the bee species had disappeared out of the landscape. 50%. That is huge. She also found that 3/4 of the connections between bees and plants had disappeared out of the landscape. That is enormous. And yet, no plants had disappeared. And that was somewhat surprising. But what happens here is when some bees disappear, other bees take over those services. And the bees that had disappeared were mainly the specialist bees. The generalists survived. And they were doing those pollination services, but not as good. The pollen deposit was only 50% of what was earlier produced. And we do see declines in seed productions locally. So she concluded that there is a lot less resilience in the system now than there was earlier, and that specialist bees are more likely to go extinct. Similar results were obtained by my friend Koos Biesmeijer, who compared the bees in the Netherlands in areas of 10 by 10 kilometers, for the areas he could do that, for a period before and after 1980. And what he found overall was that there was a substantial decline. The average species decline in bees in Britain was 29%. In Holland, 32% of the bees had disappeared from most of the blocks. So there are high declines, and he also found higher declines among specialist bees. Why specialist bees? Why are they declining? Well, Jeroen Scheper, he published a paper where he looked at pollen on the legs of bees. And he compared the period before 1950 to the period after 1970. And what happened in this period was intensification of the agriculture in Holland. And what he found was that there were bee declines, so bee declines in this sector here in the bees that had not switched to other pollen sources. They had stayed with the same pollen sources. They couldn't switch for some reason. It didn't fit in their diet. They can't digest some pollens. This is what happens with native bees. And the bees that increased had actually switched to the weeds or crops that were now more abundant in the landscape than they used to be. So there are species that increase. So it's not all hopeless, but it is a bit hopeless when you think of the number of species that have disappeared and are still disappearing. So that importance of habitat for bees is also what is found in general for insects. Remember at the beginning of this year, there was a big kerfuffle about 40% decline in insects. And that paper also analyzed what people thought about the causes of these declines. Well, 80 of the reports and the majority of the reports for the majority of species groups said habitat change. That is the main cause of declines in insects. Okay, so now we know there are no honeybees but what happens in Australia? Well, there are no honeybee declines in Australia. There is no Varroa mite in Australia. There is no colony collapse disorder. There is no deformed wing virus. Feral honeybees are doing really well. We're actually the lucky country here. But there is drought. And beekeepers struggle to produce honey at this moment because there is very little nectar in the environment because we have such a dry spring and summer. So when a beekeeper says, I can't find food for bees, generally he means, I can't produce honey. And that is fair enough. They have a business and they want to produce honey. And if the food's not there, then they cannot do their business. And what about Australian native bees? What do we know about declines in Australian native bees? Well, not very much. Native bee declines seem likely. Why? Because in Australia in general, only 60% of ecological assemblages are intact. And Australia is actually a global hotspot for extinctions, unfortunately. But we have no baseline data for native bees. There are 1,700 described species, as I said, but there are still many undescribed. In the last 4 years, with other people together, we described 42 new species that hadn't been found before. And of the 26 new species that, in a paper that came out on the last day of last year, at 6 o'clock in the evening, we had found that 50% of those species had not been caught in the last 30 years. We found them in museum collections, could say that they were undescribed species, but they had not been caught in the last 30 years, which is sort of a worry. Are you describing species that don't exist anymore, really? It's very possible. In the coming up, we are describing 10 new teddy bear species. Teddy bear species are fairly big species. It's amazing that you can find so many new things. I think we are greatly underestimating the bee diversity we have, and we have to protect it. So professional entomologists are really worried about insect declines and are increasingly publishing about this and increasingly getting together about this. I have anecdotal observations only about bee declines. When I go to intact native vegetation on a nice day, lots of flowers in spring, I will easily catch about 50 species. When we put in a lot of effort to go to apple orchards, over 3 seasons, we find 16. When we sample on a very regular basis over 4 months a grazed area, we found 12 species. So there are significantly less species in modified landscapes. And modified landscapes, we know, are on the increase. There's better evidence. I had an honors student was lucky enough to have a really good honor student 2 years ago, Amber Spronk. And she compared patches, small patches of more or less intact bushland with patches that were grazed on the eucalypt trees. And what she found, she made plant pollinator networks. What she found was 22 bee species in the bush, in the intact patches, and 12 in the grazed areas. She found 15 plants visited by bees in the bushland and only 7 in the grazed areas. 46 feeding connections versus 20, and 5 times as many bees in the bushland as in the grazing areas. So when we modify the landscape, we do get rid of bees. And there is less resilience in those systems. We also know of a species that has actually gone locally extinct. The green carpenter bee, one of my favorite bees. I did my PhD on carpenter bees. They are big bees, like that. And you can study them really well. So the last record of this bee was on mainland Australia in 1906 and in Victoria in 1938. Its current distribution is really funny. They occur a bit in New South Wales, and they occur on the western half of Kangaroo Island. And the cause of extinction is no doubt for the most of Victoria and South Australia habitat clearing. They couldn't find enough food or nesting substrate. And I will talk about nesting substrate too, but it is likely to be also large bushfires. Now, the carpenter bee uses 2 types of nesting substrate on Kangaroo Island. Big Banksia trunks that have been growing, have died, lost their side branches, acquired white rots, and then the wood becomes soft enough for the bees to nest in, but the bark has to be entire. They're very, very picky. The other substrate is dead grass tree stalks. Now, grass tree flowers profusely after fire, and then from 2 to 6 years after fire, those stalks are available to the bees to nest in. But, so in 2007, Flinders Chase National Park burnt down nearly completely. And the bees used the dead Banksia stalks that were partly, the dead Banksia trunks that were partly burnt, and they used the grass tree stalks. But then 6 years later, all that was gone. And the Banksias needed to regrow because they don't survive fire. So the bees had no place to nest. And we were aware of this. We were aware of this relationship. So supported by the Nature Foundation and the Royal Society of South Australia, together with Remco Leijs and Richard Glatz, we designed artificial nest substrate. And it took us a number of years to make that. It wasn't just there, it didn't just work, but 2 years ago it finally worked. And last year and 2 years ago we put out 300 of those stalks, and we now have 150 active nests in Flinders Chase National Park, which is amazing. But that Banksia is growing, but only this size now, and we need to keep this up for the coming 25 years until that Banksia has grown and died, etc., etc. That costs $5,000 per year to keep that up, and this is where you can actively help. And this is an unashamed plug. You can go to the website of the South Australian Entomological Society, who are supporting this project, and you can donate money there. We don't need a lot per year, but we need it for a very long time. So if you want to know more, you can also get a leaflet. I printed out 200. I hope that's not enough. So make a tax-deductible donation to the Australian Entomological Society, please. What happens when bees decline? That is a totally different question. Well, of course, we get bad pollination. We don't get the beautiful quality fruit that we're so used to. Or sometimes fruit won't grow at all. We get crooked apples. we get not so nice trusses of tomatoes, not well-developed strawberries and blackberries. Yeah, well, forget it. So poor pollination, what does it do? It leads to an increased demand for managed hives in Europe and USA for pollination. That's why little honey is produced there. When that demand cannot be met, wherever labor is cheap, we get hand pollination. And we see that. In some areas in China, apples, pears, tomatoes, and kiwi are hand pollinated. In Brazil, this started also with yellow passion fruit. Now, yellow passion fruit is not pollinated by honeybees. As I said, there's horses for courses. Honeybees are simply not big enough to reach that pollen there. So you need a big bee, you need a carpenter bee to do that. And as we know, carpenter bees rely on wood. And if there's no forest in the neighborhood, there won't be any carpenter bees. And then there might be hand pollination. But when labor becomes more expensive, and this happened in Brazil, then people change to non-pollination dependent crops. And this is how you can slowly lose your yummy fruit. So, Varroa in Australia, when it comes, it will lead to the loss of free pollination services. It will reduce crop yields through bad pollination. It will increase the demand for managed hives. In New Zealand, we've seen that, increases of 300% per hive. The large beekeepers will do well with this, really. And I think that in Australia, that price will go even higher. So what will happen? Well, if the feral honeybees die, we don't know really, because we don't know how many there are. So we're left with managed honeybees and native pollinators to pollinate all those crops that you see that are out there to pollinate. So we are trying to measure the density of feral hives. And the way we do that is great fun. We have a helium balloon, a big helium balloon, and underneath it is a trap. And in that trap is a lure with queen pheromone. And we let it up high in the afternoon, and the drones come swarming in. And we then have lots of drones in that trap and take it down, and we get the DNA from the drones. And from the DNA from the drones, we deduce how many hives are out there in the landscape. Well, that is the idea. But we do that together with the University of Sydney, and we at the University of Adelaide thought, well, I'd like to check that really. So Lizzie, who is sitting there, actually developed a method. She was a third year, and as a third year, she developed a method to get the DNA from the hives up in the trees with a really long pole with a flag on it. And they stung that flag, and from the stings, we got the DNA of the workers, and we deduced the DNA of the queen. And then we compared the DNA of our queens to the ones from the inferred, that were used to infer the queens with the drones. And we noticed that a lot of hives had been missed. About half the hives had been missed. So we are still underestimating. We're still developing the method, really. But we are working closely together, and it's great fun to do this. Lizzie will start an honours project on this in June. So we also quantified some free pollination services. Take lucency, for example. It's 100% reliant on pollination by bees. The value is 100 million per year. 2/3 is grown in irrigated areas. 1/3 is grown in dry land. And in dry land, 2 out of 3 growers do not put honeybee hives on their dryland lucerne. So that is a value in free pollination of 22 million per year. That is substantial. We stand to lose that largely because it's largely feral honeybees. So that is an issue. What happens in nature when we lose pollinators? I'm not going into that because I'd be talking forever. But we do see temporal mismatches between spider orchids and minor bees due to climate change, pollen deficits, inbreeding depressions, less seed production and less resilience, as I said. So, what can we do about it? Finally, I'll get to where I want to be. What can we do about it? Panic? Nah, it's not very productive. We need to prepare. So biosecurity is very, very important, and we're doing that. We're having sentinel hives, we're checking cargoes, we're doing everything we can to keep that Varroa mite out. But we need to prepare in different ways as well. We need to now increase the demand for managed hives and market it so that we have more hives. We need to increase the health of managed hives and increase native pollinator populations. And to do that, we need to create healthy environments for those bees. And in comes the project Andy was talking about, secure pollination through revegetation. We are trying to do that. It's Rural Industries for Profit project funded by the Department of Agriculture. And it's got a lot of people in South Australia collaborating and giving us advice and steering it. There's apples and lucerne and almonds and beekeepers, NRM boards, Trees for Life, Greening Australia, land care groups. They're all interested in contributing to this problem, which is fantastic. What we do first is we want to show growers of pollination-dependent crops that native vegetation is important for them. And Scott Groom from my group is doing that. One of the things he's done is he's looked at a native vegetation strip in lucerne areas, and he has looked at the set in lucerne in relation to that strip. And what he finds is that when you're closer to the vegetation, you get better set. Why? Because in that vegetation is where the bees are and where they forage from. So that is really great. He's been replicating that. It is now well supported, and we can calculate how much that is. This is relative to the mean of the field, so it doesn't tell you how much it is really, but it is there. And of course, the $22 million per year helps as well to quantify that. We find out what species of bees pollinate the crops, which of those native bees go there. 15 species in apple, 17 in lucerne, 16 in canola. We are documenting that. And then we find out when those bees need food, because crop flowers for a short period of time, and bees have often several generations and need food afterwards. And what we find is that when we take all those pollinators together, they need food nearly year round. So, and then we look at what other food plants do those crop pollinating bees use in the landscape. And Donna has started her PhD a year ago, and she looks at how important it is to plant high diversity versus low diversity. And she has very good results that show that if you plant only Dodonea, Acacia, and Eucalypts, you will not really increase your bees. There's not enough food out there for them. You really have to diversify to support insects in general. So that is really interesting. And based on all that, we design plantings to support bees in the crop. They are specific to the crop. They are specific to the region the crop is grown in. And we make sure that the plants we advise about will actually grow and not wither and die. We phrase that support for the growers, together with Trees for Life and Greening Australia, who know their stuff. We design different types of plantings. Hedgerows are great in apples, under tree plantings, in grazed areas, and whole area plantings. We quantify the costs and benefits for the grower, that they know how much they put in versus how much they get out in pollination terms. We'd like to do it a bit more in other terms as well, like biocontrol, etc. But we haven't got that yet. And then we also do demonstration plantings. We do direct seeding in the proximity of canola, and also planting seedlings. And if you're interested in that, to help, we're doing this in Keith in July. Find me on email and send me an email, and I will get you in touch with the people who are organizing that with Nick Gelly. So advice will probably later in the year or early next year be available through PIRSA, through Trees for Life, and through the industry websites. And that last thing is very important because that means that farmers can actually access it and use it. And we will be promoting that. Now, I told you what we are doing. What can you do? Well, you can help by supporting the carpenter bee. You can also plant bee food, and you can make others plant bee food. You can go to your community and say, please don't put in mondo grass because it's not bee food. Please put in Australian native plants. There's also things that are counterproductive. One of them is when you grow stones rather than plants in your garden, right? The other thing is when you say, bees are doing it tough. I'll take a beehive. What did I say the problem was? Not enough food in the landscape. What you're doing when putting in a beehive, you're taking out 80 kilos of nectar and 8 kilos of pollen. From that 80 kilos of nectar, 20 kilos of honey is made. So that is approximately what it will be. And that nectar is also food for a lot of native animals, such as honey eaters. So adding a beehive is really not helping. We're gardeners. We can plant bee food. Local native species, talk to your native nursery. They generally know what is attractive to bees. Eucalypts, Hakea, Grevillea, tea tree bottles, Christmas bush, Bubiala, and bluebells, fanflowers, goodenia, and buzz pollinated plants. There's a wealth of plants out there for every region. And if you want gardening tips, visit the Adelaide Hills and Mount Lofty Ranges NRM website and look for the Native Bee B&B project that Sophie and I did together. They have wonderful information out there. I put it on. So, are the bees declining? Managed honeybees, not so much. They're managed. Feral honeybees in the rest of the world, yes. In Australia, no. Native bees in the world, yes, due to habitat change. And honeybees where they are declining due to pathogens largely. Pesticides play a role, blanket role for all of them and for all insects. If you're a gardener, just don't use them. This is happening partly in Australia as well, but not for the feral honeybees and not for the managed hives. And what happens when the bees die? We get less pollination, pollinated crops. What can we do? Plant bees. Are we all going to die? Yeah, we are. We'll be outlived by the bees, probably. I like to thank the bees. They're forever an inspiration to me. I like to thank the collaborators on the Secure Pollination projects, which are nearly as much of an inspiration to me, and other collaborators. I'd like to thank all the organizations that contribute to that project and do it with so much enthusiasm. And lastly, I would like to thank my own team, the Team B from the Waite Agriculture, Food and Wine. And if you want to know more about native bees, I've got some books with me that you can look in and order if you want. I've got them all three here, so you can have a look at them. And I thank you for your attention.
Okay, well, thanks very much, Katja. It's a fascinating talk, charismatic microfauna, perhaps. And probably some people are going to be interested in some of that information. So just go through again where they might get the information, particularly on where to plant bees.
Okay, Plants for Bees is on the Adelaide Hills and Mount Lofty Region NRM website, where you Google native bee B&B. We called it native bee B&B because we're putting in bees hotels, but not only bee hotels, bees and breakfast. So, so that is where you can find information about plantings.
And from the large-scale project that you talked about, there will be information that will be distributed through PIRSA and through some of the NRM networks, hopefully starting later this year and continuing into next year.
Yes.
Yeah. So before Katja came up to talk tonight, she said to me, I'm a bit nervous, I've never talked to such a large audience, and I'm not sure that I'm going to be able to connect. I think she did a pretty good job at that. And so I'm sure, yeah, okay. So I'm sure you've got some questions now, so I'd like to throw it open to the audience. We have some roving mics, we have one there, we have one at the back there, so stick your hand up, hi. There's one here, I'll try and help direct, and we've got time for a few questions.
Katja, thank you for the information. I live in the Adelaide Hills, and one of the things that we were concerned with this year was a lack of pollination in the vegetable gardens, including tomatoes, cucumbers, etc. And it wasn't just me. I asked around a lot of neighbours, and it's like a rapid fall off this year. That was my first question. The second question is, why do governments in this country allow the importation of honey from other countries?
Okay. The first question is not as difficult as the second one because I'm not the government. But the first question, well, I have noticed this too this year, and there have been one of the bees that really contribute often, and you see them often, is blue banded bees. Most of you people here would know blue banded bees, have seen them. If you haven't seen them, they fly like this, and they love lavender. And they go for your tomatoes and cucumbers as well. It's been a very dry October, and I think that, and I don't know, but I've worked with blue banded bees for years, I think that if it is so dry that there is not much flowering in spring, which was really an issue this spring, the bees might just decide to skip a year. And I think they've done that. I hope they've done that. But so I think that is an issue. We have noticed that there weren't many bees out there. Yes, it's been very dry. No, they cannot reproduce very well when there is no food out there. And so there hasn't been very much. So that is really an issue, I think, and that is what... The honey, I don't know. The honey from overseas is often cheaper than from Australia, but consumers can make their own choices, of course. They can choose to buy Australian honey. They can choose to eat produce that are grown with bees and other insects in mind.
And you don't like honey?
I don't know.
Okay. Question at the back here.
Could you tell me, please, what effect do you think...
Sorry, can you speak up, please?
Could you tell me, please, what effect do you think the epidemic diseases, Varroa, etc., will have on the native bee populations?
That's a good question. I didn't say that, but Varroa will not directly affect native bees because it is in tune with the honeybee cycle. However, it is possible, and we are actually researching this at the moment. Scott, who I introduced, and Beth are working together with people in Germany to look at what effect the deformed wing virus that we don't have might have on some of our native bee species. And we actually found that some of the reed bees might be susceptible to it. So we don't know yet, but it is a very good question, and we are addressing it.
And back here.
Hello, I was wondering what the the Varroa virus might have on like future generations as effects, with like the fruits and produce and that.
On the
future effects of Varroa on crops?
Like fruits and vegetables and that.
So what happens when Varroa comes in?
Okay, what happens when Varroa comes in is there will be frantic bee breeding of managed hives and learning how to deal with that Varroa mite. And in the end, we will rely much more on managed hives than we do at the moment. And there will be a large pollination industry. Now we have a large pollination industry regarding almonds, and a bit in lucerne, and not much else. That will increase. Well, we've got apple and cherry where beekeepers go, but it's not huge. It will become much larger.
So if you're a young entrepreneur, you should start investing in beehives now, because
Yes.
when Varroa comes, you'll make a lot of money. Next question at the back.
Early on, you mentioned that bees need dead trees and they also need water. I've heard it said that bees don't actually drink water. What are they using the water for?
Honeybees drink water, and a lot of water, and they use water to cool their hive. So for honeybees, water is really, really, really important, and without water, they would not survive our summers. Native bees don't. And I think that has to do with the nectar concentration in eucalypts, which can be often low, because that is in tune with what birds want very often. And I think they get enough water out of that. I never see native bees at water spots.
Yep. And we'll take one more, I think, up at the back here. Yep.
Is there any transfer of the foul brood diseases to native bees?
What kind of diseases?
European or American foul brood?
European or American foul brood. No, they are not transferred directly to native bees. We haven't got bumblebees apart from in Tasmania. There is some interaction between honeybees diseases and bumblebee diseases, but not so much between honeybees and native bees. There are cross-infections with viruses. We can find honeybee viruses in native bees, but we generally don't see any negative effects on the native bees. And in areas where there is no beekeeping, interesting enough, this is what Beth Fung found, in areas where there is no beekeeping, we lose the honeybee viruses. So they keep on being exchanged in that environment where bees keep on being exchanged, but where there are only feral honeybees and wild bees, we found no viruses. So that basically shows that there is not really a big exchange there.
I'm sure Katja would be happy to answer additional questions later. Now, we hear a lot about jobs of the future, and I don't know if any of you saw Gruen Transfer. It's probably about 9 months ago. They had somebody getting dressed up in a bee costume and kind of trudging to work, and they had to then hand pollinate these bees. So if you want to avoid those types of jobs for the future, then please invest in bee hotels. It is the future. Anyway, I'm sure you can invest in bee hotels and come down here and get some of the brochures, but I'd like you to thank Katja for a fantastic talk tonight.
Thank you.
And also thanks to you for being a great audience and having such good questions, and for paying attention, but it wasn't difficult. So next month, in the lead up to Reconciliation Week, we'll hear from Associate Professor Rob Armory, who will discuss the Ghana language and how the university is helping to reclaim it. So be sure to sign up for Research Tuesday on the website, and thank you all again for coming. Good night.